Okay, so now we're going to go into section 10.2 in our pre-calculus book, which is about circles. And you've been hearing about and knowing about circles for some time now. You should know about the color wheel circle, that the circles can make kind of some fun designs. And the last one is this idea that circles have a circumference. They definitely have a center to them, a radius, and a diameter. And we're really going to focus in on the math of circles today. Just a reminder on how we have 4 conic sections, and circles are the first one that we're going to be exploring. We're going to go on to ellipses, parabolas, hyperbolas, and we're going to be doing that here in the process of about 2 weeks. But that's going to be our next idea here. So hopefully by the end you're going to really understand how conic sections are derived. When we talked about that our last video. Hopefully identify and use the standard form equations to graph a circle. And we're going to use completing the square to put an equation into standard form. And we're going to talk about circle, and actually is used on the ellipses as well. So here's our circle formula, and you're going to want to write down this standard formula, all right, or this standard form. X minus h quantity squared plus y minus k quantity squared equals the radius squared, okay? And if you notice, what we have here is that the center is at the point HK. All right, that's what we have here. And that our radius is that R. So I want to talk about, okay, let me give you an equation and see if we can pull out that. So here we have an equation. X minus 3 quantity squared plus y plus 2 quantity squared equals 9. In the standard form, we know that HK is our radius. So in our thought bubble, you should be thinking to yourself, oh, it looks just like a circle equation. And later on, we're going to get all the different equations. We're going to have to know which is which. But right now, we just have circle equations. We need to find the center and the center point and the radius. Well, the center point is at the opposite here and the opposite here. Kind of what makes this a 0, what makes my x a 0, what makes my y a 0. So that's where I got the positive 3 and the negative 2. Radius, I had to take the square root of the 9 to get 3. So where is my center point? I'm just going to use this red for my center point. It's at the point 3, 1, 2, 3, down 2. So there's my center point. From my center point, I have a radius of 3, which means from this point, if I go 3 in any direction, and I'm kind of counting out 3, that's going to be kind of the vertices, or some of the vertices. There's an infinite number of vertices of my circle. And if I'm really careful, I should draw a nice clean circle here. I didn't get so clean, but kind of close. So if I had a perfect circle, each point on this circle would be 3 units away from my center point, exactly 3 units. So a circle, the definition is a set of points exactly the same distance from a singular point, a center point. So what's going to happen is we don't always get to see our equations in the nice standard form that we just had. All right, so we don't have it if it's in standard form. We have to kind of do something to complete the square of x and y at the same time. So our process is, first, group your x's and your y's together. So if you can see, I said, oh, okay, here I just kind of moved everything. I moved my x over here, my negative 2, my y squared, my 18y, and my 18. That's my first step. Now, it's kind of like you have 2 completing the square processes. So if you remember, completing the square says look at your b, take half of it, in this case it would be a negative 1, and square it, and add it to one side, add it there. And what I would do is I'd add it to the right side too. And then I'm going to do the same thing for this b, for my b that's in front of my y value. Half of 18 is 9. When I square it, I get 81. And I'm going to add 81 to both sides. So that's what I did here. And it's the same thing I'm showing. I have them both in red here. Okay? So you complete the square for both x and your y. And then you write that equation down. So if you remember, it's always half of your coefficient of your x here. Half of the 18 here would be the 9. And so now you can see where that really looks like it's our standard equation. Now I can derive from there to say, oh, great. Now I can graph it. I can look at this and say, I have a center at 1, 9. okay, because here's my -1. It would be 1 -90. I apologize, I misspoke. And then my radius would be that square root of 100, which is 10. So here's the point 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the point 1, 9. I'm going to need some extra space here. I can tell it now. Now in every direction, I'm going to need to go 10 units. So 10 units in the going up is there. 10 units to the right is about here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units here. And I'm going to estimate where 10 units would be here. And if I did a good job, I should get a nice circle. That's not too bad. All right. And I'm going to tell you now, my circles are never going to look beautiful. There is an art to drawing a good circle. I never learned the art. All right. But I sure know the math of how to draw and make a good equation. So let's do another one. What if that leading coefficient is not a 1? Then what do we do? Okay. And actually, I have a mistake here. I wanted this to be a 12 here and not an 18y squared. In fact, it kind of has to be a 12 for me. So let's go on and work that through. So here, first, grouping my x's and y y's together. I'm going to make this a 96. I just didn't get everything fixed that I needed to. So I have a 12 and a 96 here. All right. And I'm grouping them together. So I group together. Make this my 12. Sorry, y squared, it's hard to see. Minus 96 and the 12x squared minus 48. What you do next is you factor out that leading coefficient. So if you remember, it's kind of like saying I'm going to divide both of these, but just this grouping by 12. So I factored out the 12 and I wrote the 12 out in front. I did the same thing with this 12. I divided this by 12 and divided this by 12. And then I got x squared minus 4x. And then here, y squared minus 8y. And then what you do is when they match, what you really do is you really kind of just say, okay, now I'm going to take this grouping, I'm going to take the 12 out of this grouping. In this grouping, I'm taking the 12 out and I'm dividing this by 12. So I kind of divided everything by 12. And so now I'm left with x squared minus 4x and then a y squared minus 8 and equals negative 120 divided by 12 is negative 10. Now I can take half of my b, which is 2, add it to both sides. All right, and that's what I did here. Oh, I did it wrong here. Gosh, sorry. I should have added the 4 here. Half of negative 8 is negative 4, which would be 16. And that's what I have there. And then when I complete the square, that's what I get. Okay? So after completing the square, I can really pretty easily say, oh, I'm going to have my center at 2, 4, and my radius would be the square root, the square root of a negative 10. That's where we get into trouble for this problem. It wouldn't be a negative 10 though. I think I mistaken, it would be a positive 10, I apologize. So it would be the positive 10 because negative 10 and 20 would be a positive 10. I'm glad I made a mistake there because that wouldn't have been possible if we had the radius can't be a negative. So radius is the square root of a negative 10, or square root of 10. And I wasn't asking you to graph this one, I just kind of wanted to go for an example. So let's look at some of these. I have a little bit more time. I especially want to look at 7. It says center at, here I'm going to grab it here, maybe, there we go. Center at 1, negative 4. Let's see if it does a good job here. Yeah, I need to cut that. All right, here we go. So you're going to need graph paper to do this assignment. All right, center at, I'm going to get my graph paper. Oh, shoot. So in number 7, we're saying a center at negative 1, 4. So here is the part, negative 1, 1, 2, 3, 4. Now it says tangent to x equals 3. Well, the line x equals 3, let me see if I can get a line here, would be about right here. That's my line. So if it's tangent to that, it actually touches that. It kind of curves and it just comes and it right approaches it. It touches it just in the one single point. So that means the radius would be 1, 2, 3, 4. So we have a radius of 4. So I can go 4 in either direction. And I can kind of draw my circle from that. Again, I'm not going to be too particular about your circles. I'm looking for here for you to identify that the radius is 4 based on that tangent. Let's do another one. Let's do here number 16. So now we have a center at -4. 1, 2, 3, 4. All right, so now what we're looking at is we're looking at a center at -4, 7. And I had my center here, 1, 2, 3, 4, up, 1, 2, 3, 4, 5, 6, 7. All right. And the square root of 3 is about 1.732. So I'm going to estimate it at 1.7. So I'm going to go 1.7 to the right. And we're just, I think the best thing we can do is estimate where we're going to be and then draw your circle. When they're smaller, they're a little easier to get exact. So good luck on this, and check in for the ellipse video.